out to work with him before? Yes, dear. Yes, dear. I got to pass this over there. Okay, we were about to do number 4. It says about find the prime number, summary, calculate the IQR, determine the outliers, draw a box plot. Is there anyone who would like for me to work this problem now? Okay, then after school I'm going to take a couple minutes and record me going over this for those who want to know. But I get it's a repeat topic, so it's probably something you already got. Or if not, you're getting there. Okay, so flip to the last page of our notes. There is only one new thing we're going to talk about today. So far, if we had to review all the things we've talked about, like most important, categorical and quantitative. We talked about how to display our data. We talked about cussing. We talked about the 5-number summary. And now here's our last important thing for this chapter, and that is standard deviation. Okay. So the standard deviation, it measures the average distance of the observations from their mean. And what on earth does that mean? Okay, well, if we had what we thought was the mean, I'm going to draw a line the way your math teacher used to just graph a line. And let's say some of these points are part of our data set. And let's say I put one way down here, maybe one real close by. The standard deviation is measuring how far away our points are from that true mean, meaning that blue line. So we're wanting to know how far away our actual data from what we thought our data would be. And if that doesn't help, then maybe this will. We discussed that the mean, what's under me? Something's under me. Slow me down. We talked about mean helps you measure the center of the data. The mean gives you the average center of the data. Well, the standard deviation, it's the true, accurate way to measure the spread.
So median is the mean as ranges to standard deviation.
Yes. Actually, I would say as IQR is to standard deviation, because median and IQR, median and IQR resistant to outliers. Okay, so standard deviation is really cool. However, like the mean, it's easily swayed by a non-centered data. So if our data is not symmetric, then we don't need to use standard deviation. So the first thing we do when we get some data is we plot it and we look at the shape of the graph. We go back to cussing. Because if you don't actually cuss and look at the shape of the graph and you just start applying mean and standard deviation, it might not work. Because unless the graph is symmetrical, it's not going to work. Because, like I'm saying, the standard deviation and the mean are both affected by those outliers or those tails or whatever. Okay. There's a fancy formula. It is on your AP sheet. Remember we got that giant page of formulas the other day? There are actually 2 different formulas. We'll look at both in just a second. I know my Cal kids know what this means, but for those of us who are in regular world, and I drew mine super ugly, that epsilon, it actually stands for summation. What math are you supposed to do if something says sum? Yeah, so we're going to end up just doing addition. Calculus makes summations so much more complicated, and that they do so much more stuff. For us, we're just going to add up some stuff.
We're going to purposely make math why do you have to draw that symbol? Just say add. That looks me so much.
Just add. Okay, so otherwise in that formula, What do you think the N is for?
Number of values.
Okay, so that's going to be, and they're going to tell us the number of values. And then X bar is,
The mean.
and then the only one we don't know up there right now would be the XI, and that's going to depend upon that specific data point,
That's the initial.
or maybe initial value, but we're going to plug in each of them. We're going to plug in the 67, the 72, we're going to plug in each.
Oh, that's cute.
Oh, we're real cute. We're real cute. Okay, so we have an example, so those of us who don't speak math are like, what is that? Can follow along, because I swear it's not that complicated. I'm going to go to my list. I'm going to type in those 5 things. 1, 2, 3, 4, 5. Those 5 things. Plus the problem said 5 starters, so woohoo. So I go to my list. I type in, again, stat and then edit. And in my list, I type in the 67, the 72, 76, 76, 84. And then, as discussed before, you can say stats, calculate those one variable stats, and it will tell you all the things you need to know. X bar is 75. Now, was that absolutely necessary for this problem?
Yes.
When there are only 5 starters.
No.
So if we were being lazy, what could we have done?
You added them together in the 5.
By 5. And that's what I did earlier when I did it, because I was being lazy. Why would we want to do one variable stats instead?
So that we already have the list pulled up and if we need to do other stuff.
So he's a genius. We're about to need the other stuff on the list, so it's smart to go ahead and have the list pulled up from the one variable stats. Okay, so we found the mean. Can you help me interpret it? I typed in my list those 5 values, 67, 72, 76, and then I looked on my calculator and it says X bar is 75. Then you type a number extra on your list, probably. Okay, so X bar is 75. Can someone help me interpret that? Interpret it. What does it mean?
The average height of basketball players.
75 inches. The average ball
6'3".
player is 75 inches.
Look back by the list.
Yeah.
Did what happen?
I mean, there's 84 inches on the list, too.
She said that's the average.
The average.
Oh, okay.
Yeah. but-
The average basketball player is 75 inches. And we just had to interpret the mean. You know, mean is average. So the average basketball player is 75 inches. Everyone go with part 1.
Yes.
Okay, if we go to part 2, it says make a table that shows for each value its deviation from the mean and its squared deviation from the mean. Okay, so there are 5 players that we're talking about. So I'm going to say for part 2, there's player 1. And then I'm getting lazy, so I'm not going to write out the word player. I'm going to say P2, P3, P4, P5. For the 5 players.
Oh, do you have to like subtract the mean each individual height?
Yes.
That's gross.
So in the next column, I'm going to do X minus X bar. And all that means is I'm going to take however tall they were. For instance, this guy was 67. Next guy was 72, 76, 76, and then 84. And I subtract my mean. And we just found the mean. The mean was 75. So from every single player, I'm going to subtract 75. Okay, and then I shouldn't have drawn my green line. If I could redo my life, I would. What is 67 minus 75?
-8.
What is 72 minus 75 is -3. That's 1, that's 1. What's 84 minus 75? 9. Okay. -9, right? Or is it positive 9? It's negative 9.
No.
84 minus 79 is positive 9. Jeez Louise, what's
What
something?
is that? X minus what?
X bar.
X.
I did X bar. I should not write in pink, should I? Okay. So you and I have calculated X minus X bar, and to be honest, that should be its own column. We did X minus X bar. We got those numbers. So if we read through the problem again, it said it's deviation from the mean, and that's what you and I have calculated. This pink column is the deviation from the mean. But that doesn't really help us with anything, so we always square it and find its squared deviation. So I'm going to take the X minus X bar, and I'm going to square it. Meaning I'm going to do negative 8 squared, negative 3 squared, 1 squared, 1 squared, and 9 squared. Now, why would we square something?
To make it positive.
It's always positive then. So what is negative 8 squared? 3 squared, you know that's 9, 1, 1, and the last one is 81. So we've got these values, these X minus X bar squared, and that is the squared deviation.
We're gonna make that square standard.
We've got to standardize it, which means we're going to take the square root of it and do some fancy stuff to it in just a second. Step 3 says, show how to calculate the variance and standard deviation from the values in your table. So I don't think I did a good job of pointing out what variance is. This average squared distance is called the variance. The average squared distance, which is what you and I found, is called the variance. So it's the standard deviation squared. Variance. Anyway, there's a formula for it up there at the top. It's not very useful. Again, we like to square things and square root things. I get it's stupid to square root something you just squared, but it's all to standardize it and make everybody positive. Okay, so it says we want to calculate that standard deviation. We've got us a fancy formula. It says S of x equals square root of 1 over n minus 1, and then something about summation xi minus x bar squared. So life is looking pretty complicated. How many basketball players are there?
5.
So what should I plug in for n?
5.
So I'm going to have 1 over 5 minus 1. And then I have summation of x minus x bar squared, but I'm not even going to write that. Again, what does summation mean? So, and we're adding up the x minus x bar squared. Don't you and I have a whole column of those? So let's add up. What's 64 plus 9 plus 1 plus 1 plus 81? What do they add up to?
156.
156?
Yes, I agree.
75.
Yes.
I agree.
Batman concurs.
No, I agree too. Okay, so you and I have actually done this part, so let's plug in our number, 156. And so we have square root of 1 over 4 times 156.
Yeah,
39.
So square root of 39, and I want that decimal to at least 2 decimal places.
So do we not square it?
6.24.
6.2. Okay, and then back to Olivia. Ma'am.
So like we added all them up and put it in where the x and stuff is, but do we not square it?
Yeah, you and I already had this square column, didn't you? We had this x minus x bar. We haven't. We just haven't done the summation part. So by adding them all up, you and I have done the summation part.
Okay, so the exact.
Yes.
Okay.
So you're
Okay. So life seems pretty good. We got 6.24. And so what we're supposed to figure out with this is we found the mean is 75. And then, so on average, people are about 6.24 inches away from that mean. Meaning on average, people are 75 plus 6 is 81. So they're in between, what's 75 minus 6? 69. So people are in between 69.24 and 81.24 inches tall on average. That's what that's going to help us say.
Between 5, 9, and 7.
So,
Wouldn't it be like 68 point?
yeah, you shouldn't let me do math in my head. It was bad. Okay, so back to step 3. Does everyone understand how we calculated that standard deviation from the values in our table? How we used this column to help us plug in that formula? Are there any questions of how we use this column to plug in that formula? Yes, dear.
It's not a question about how to plug in that, but like that's on the list on the calculator. So
God bless you for knowing these things. We might have to actually, geez Louise, words. We might actually have to calculate this occasionally, but more than likely, we're just going to look at our summary on our screen, and my God, it already says S of X is 6.24. So notice on your calculator, if you've still got your one variable stats pulled up, S of X is 6.24.
God bless calculators.
God bless calculators, they do all the work for
I just
us.
moved up from my 18th grade invention to my 4th.
Okay, so got this calculator. Are you okay, babe? Yeah. Okay. And we're supposed to interpret. So Ms. Compton was making some grand generalizations about she took 75. Second quit. Second quit. Go away. Second quit. Why won't you quit? $75 minus 6.24. So 68.76, and then 75 plus 6.24, and you get 81.24. And we would say most people, in fact, we're eventually going to put percentages on it, most people are between these two numbers.
Salary.
Or we would say most people are, this number is how many standard deviations away from the mean.
So, see all those numbers in the letters on the board? Instead of doing all that, you can just find the answer on the calculator.
Yes, but you have to know what it means.
Gotcha.
And then if you wanted to, and so Ms. Compton's being ridiculous by trying to apply it to specific numbers, we could just more generally say when it says interpret, we probably don't have to be that specific. We could just say on average, there's a spread difference, there's a of 6.24 inches between a player and the mean. And then I swear I'm butchering my words on part 4, so we'll probably have to revisit my part 4 on how to interpret. I did not do a good job interpreting that. So you probably want to put a question mark. Like Miss Compton has lost her mind at this point. She's gone crazy. Eventually we're going to start talking about how many standard deviations we are from the mean. It turns out if you're 1, then it's like 67% of data falls in here. If you're 2 away, 95% falls in. But that's another day, another time. So we'll pretend we're done with part 4. And we'll go to part 5, which is the part that the genius was on. And she said, hey, my calculator already said S of X was 6.24. And so my question is, what is the difference between this symbol and this symbol? We talked about it the other day. There are 2 different symbols on number 5. And there are 2 different symbols on my calculator screen when that one variable stats. How did she know to go with the S of X and not the other, the omega?
Because it says S of X is the thing not the other thing.
We talked about this the other day. What is the difference between these two? What is the difference between these two?
The S and omega.
What's the difference?
One of them is
There are 2 different types of data besides the quantitative and categorical.
the mu is the average.
It's not the
Oh, make me sad.
Sorry.
We talked about some. We didn't know if it was a random sample or if it was a population,
Oh.
and that there were 2 different formulas for them. So if we're measuring an entire population, if we're actually trying to apply this to all the NBA, the entire population of the NBA, then we would use the other. But since we're just talking about these 5 players on this one team, it's a sample, so we're going to use that S. Okay, and then there are a bunch of words. If we have a choice if you have to choose median, IQR, mean and standard deviation, how do we know which one to use? Again, it depends on the spread of the data. You can always use the median and the IQR because they are resistant. However, if you already know that your data is symmetric, the mean and the standard deviation are better. So for the love, look at the spread of your data first. Decide, is it skewed left, skewed right, symmetric, etc.
I have a question.
Yes.
What is the difference between discrete math and AP stats?
Discrete math does not do any of
Oh,
these
sorry,
things.
Discrete math and pre-calculus.
Discrete math does the opposite of continuous functions. All you do in pre-cal and cal are continuous this, continuous that.
So
Well,
is the discrete
no.
math, like, more fun?
No, it's more computer theory. Like, we're going to talk about binary encoding and, like,
That's fun.
yeah, but it's people who don't like math, so we have to dumb down binary encoding, and we don't actually get to the fun part. Like, we say fun stuff like PS, Netflix uses matrices to figure out which movies to recommend to you,
Sure.
but then we actually don't get into the math of how Netflix does that, because all we can do is multiply two matrices, because that's all we can handle. Yes, dear.
I was taught how to count to 31 in binary. I don't know that again.
You are so cool, then. Oh, that is so cool. You have to show me all the things. So you know the hand trick, then.
Yeah.
Okay.
At
Yes.
least I think I do.
A kid in discrete 2 years ago had to teach it to me because I didn't know that.
1, 2,
Discrete sounds
Or-
like fun.
8,
Yeah.
16.
Yeah, you know things. You would be fine.
Way.
Yes, probably. It probably is. I could stop recording. This got random. Oh,
May I have your attention, please, teachers
No.
and students, everyone.
That's ugly of me.
Nothing